Hello and welcome back to this ongoing video series on the Arturia Moog Modular. And as promised, we're now leaving behind the module by module section of the tutorial, and we're going to dive into some actual sounds and figure out how the sound engineers at Arturia have built these presets from basically reverse engineering them. So we're going to start with this sound. This video is going to deconstruct this sound and figure out how it gets there. And immediately what we can see is that it's using two different VCAs. The input to this VCA is coming from different modules to this one. So it's basically two sounds combined together, and that's going to create confusion and clutter. So let's take one of the sounds away. And we've just got that. And having done that, for now, let's throw away everything to do with that second sound source because it's just getting in the way. So this cable comes from here, so we don't need that, and we don't need that. Do we need this cable? Nope, that cable's not doing anything anymore. Throw that away. Okay, so that's our simplest left-hand side version of the sound. And we'll come back and put all that right-hand stuff in later, don't worry. But for now, we're just dealing with the left-hand side. So how is it making this horrible kind of static based noise? Well, what we want to do first of all is take a snapshot of this instrument as it stands right now. So I'm going to save this preset as test 1. Save it. And now if we lose the sound, then we can always come back in, load preset, and get back to test 1. So that's our current sound. Now the first thing that I can see is that it's using one driver. But over here, so driver 2 is completely unused. There's nothing going on in that bank there. Driver 3 has something going on with this oscillator. So this slave oscillator is being used in some capacity to modulate driver 1's sound. Let's figure out how. Well, we've got a sine wave coming out and going in to this modulation source for the coupler's frequency level. So this coupler, this is basically a filter, and it's set to band reject, which basically means it's going to throw away a section of the frequency range. And the amount it's going to throw away is controlled by this bandwidth knob and this frequency knob. So it's just like a moving slider of what it's going to throw away. And that frequency there is going to be modulated down, as it happens because it's a negative number, by this sine wave. So it's basically going to do this kind of thing. Move the section of sound that's going to be thrown away by this filter. And the speed at which that oscillator is going to flap away is being controlled by a noise generator, and it's white noise that's coming out into this frequency modulation here, which basically means it's random where that at any given moment in time where on the sine wave cycle that frequency modulation is going to be. It's going to be random because it's being modulated by a noise, by this white noise output, which basically generates random signals. We can see what effect that's having on the sound by taking this bit out of the loop. So now we have a constant kind of thing. And now Don't forget, this is an effect that's being applied to a filter. So this isn't a pitch modulation, this is a filter modulation. It's changing the amount of filter that's being applied to this sound, and what we're ending up with is that kind of static sounding chatter. Okay, I increase the FM, make it more dramatic. Now we've got complete chatter. You can hear. That's a filter sweep going on there as the band reject. Okay, so that's what's going on here. White noise generator coming into a frequency modulator of an oscillator that's not being used to generate sound. It's just a sine wave. The sine wave's coming out into this filter here and variably affecting the frequency of the band reject, which bit of the sound is being thrown away. So that's what that's doing over here. What else have we got? Well, the main sound is coming out of this driver here. And what we're going to do is I'm going to throw away everything to do with filters or LFOs. We're going to get down to the pure tone and find out what's underneath this sound. So I don't want any of these noise generators. This LFO is doing stuff. Let's not have that. Don't want any. Oh, we'll keep that in. Don't want this here. Okay, so now we've got a pulse wave coming into a mixer, coming out of the mixer into a couple of filters, and then off to a VCA. So we should get a more normal kind of tone now. Still kind of pretty grim. But at least we can hear tones. So everything else that's going into this oscillator is affecting that core sound. That's the bass sound that we've got, and we're getting that sound from this pulse wave going into a couple of filters and out again. If we bypassed all the filters, make it even simpler. Okay, so that's the absolute raw sound. Plug the filters back in. So the difference in those two tones is what's being generated by these two filters here. So the first filter, the coupler, you can hear it cutting whole chunks of the frequency range away. Again, let's just take that out of the equation completely. Drop this in here instead. Bring it back in. Okay. If we take the second filter out, what would we have? Okay, so the combination of those two filters together is shaping the sound that we hear. So that's quite tonal. Let's go back to our bass kind of left-hand side sound that we had. So I'm playing C, B, A, G, A, B, C, and you can hear them. A lot of that tone's gone because it's being masked by all these noise generators operating on the frequency modulation of the oscillators, basically kind of corrupting the sound, if you like, taking away its tonality. So we've already had a look at this oscillator over here, and seen what effect that's having on the sound. If we want to temporarily take that away without throwing cables away, just change that modulation amount. It was at 0.26. Change that to 0. So now it's not having any effect. This here is not having any effect on the sound whatsoever. We get that. Then we've got, let's have a look at what's going on here. This is an LFO cycling at 6.5 Hertz. So it's like really quick. You can see the light flashing. I couldn't count that fast. 1, 2, 3, 4, 5, 6 kind of thing. And it's got 2 triangle outputs going to the frequency modulation jacks of these 2 oscillators. We'll deal with this oscillator in a minute. It's a sneaky little thing. Let's deal with this one first. So a triangle wave is coming in and affecting the frequency modulation in some way. Best way to find out what an effect is doing is make it more dramatic. It's doing that. But that's obviously at max. We pull it back down to where it was. It's still doing that thing, but just more subtly. A lot of these effects are applying subtle changes to the sound that build up a composite effect. And the other cable is coming in over here. So listen to that one. Okay. Now then, I said this was a sneaky little bugger, this oscillator, because it doesn't look like it's plugged into anything. Let's have a look at what's going on. We've got the left hand slave 1 of the driver, and we can see that we have a pulse wave coming into the mixer, coming out of the mixer, and then going on its merry way. That's fine. We understand that. Don't think that link button's doing anything. There's nothing in this second mixer. So let's ignore that. I think that's probably just an artifact of some sound designer. I don't think that's having any effect because there's nothing going on with this little mixer block over here. So there's no reason to link them together. But this oscillator here has got an input coming from the LFO, but no outputs. None of the 4 output jacks have got anything plugged into them. So it looks like it's not doing anything. See this, it says 2 octaves below. It is doing something. So how can it be doing something if it doesn't have any outputs? Well, there's a 5th bizarrely hidden kind of secret output in these oscillators, and it's this innocent looking black socket here. It's like a button kind of thing, and you can see there it's set to sync none. That's fine, but over here this is set to oscillator 2 sync. What's going on? What that means is that there's a 5th output, like an internally wired output from these oscillators that generates a square wave that can be synced to another oscillator somewhere else. And what this is saying here is sync oscillator 2 to me. So this is the master oscillator, and this is now the slave oscillator of this kind of master, even though it's called slave 1. So that's slave 1 oscillator, but slave 1 is now a master of oscillator 2. They are synced together, they are linked together, which is why when we press a note and change the frequency range of oscillator 2, we're having an effect on the sound when it doesn't look like we should. So there's a 5th like secret square output, and it's being plugged into this oscillator's secret invisible input via this thing here. Now this sync switch underneath, you see that they're actually joined together, these two things. When this sync button is down, it means the sync is what's called hard, which means every time the slave wave triggers, the square wave kind of oscillates, then it re-triggers the first wave, so they're always perfectly in sync. In soft mode, which is when you flick the button the other way, it only triggers when the first wave is about to finish. Basically, if it can sync them together, it does, but if the two waves are out of sync, then it doesn't sync them together. One of those things that it's almost impossible to explain, because I'm not an electrical engineer, I'm not an electronics engineer. I understand how these things sound without necessarily being able to explain them very well. But the bottom line is that when you see these things synced together, very often the sync will be in hard mode because you want to sync these two oscillators together. And now oscillator 2 is having a direct effect on oscillator 1. These two things are basically operating in tandem through this invisible fifth square wave. So if I make this really dramatic, that's why we can hear it, and why if I take this away, these two things are working in tandem. So all of that is having this nasty noise effect. This oscillation that's going into these two things over here, doing that kind of thing, is that. Okay, so that's the left hand side. That's how we're generating the noise side of the signal. Let's go back over to the right hand side. So we'll reload the entire patch, turn the left hand side down. That's what's going on the right hand side. So again, similar kind of thing. Now we can throw away everything on the left hand side. Use all of this. So we've had no effect on the sound whatsoever. All of these cables are feeding into VCA1. And finally that one. There we go. Okay. So this is nice and simple. This is not going to take us long to figure out this one. We've got a modulation cable plugging into the modulation input of this low pass filter. That's the modulation wheel applying that effect. What else have we got? Here we've got an oscillator not connected to a driver. It's going directly into the filter, so we have no independent mixer control of this oscillator. The slave, the triangle, is going straight into the filter's input and then out of the input to the VCA, so that couldn't be any simpler. And the only thing that's being done to the sound is a little bit of frequency modulation from a triangle off the same LFO that's feeding the noise that we're hearing in the left-hand VCA. So they're pulsing at the same frequency. Okay. And we can also see that the fade-in is set to 300 milliseconds. When I first press the note, it's static and then it starts warbling. And that's it. Really, really simple stuff for VCA2. And when we join those two things together, we get that. Hope that's been useful to you. Join me next time and we'll go through another preset together. Thanks very much for watching.